Hi guys, so today we're going to be talking about momentum. So any object that's moving has momentum, and we can calculate an object's momentum by using the equation P equals mv. So P equals mv just means that an object's momentum can be calculated by multiplying its mass by its velocity. So because the units for mass are kilograms and the units for velocity is meters per second, if you multiply these together, we get the units for momentum, which is kilograms times meters per second. It should also be known that momentum does have direction, so it is a vector quantity. So just to do a quick example demonstrating this basic equation, we have a 1,000 kilogram car and it's traveling with a speed of 18 meters per second. So if we wanted to find its momentum, we would use the equation P equals mv. We would plug in its mass of 1,000 kilograms multiplied by its velocity of 18 meters per second. So we would get its momentum to be 18,000 kilograms times meters per second. So we can apply this basic concept to one that's a little bit trickier, which is the conservation of momentum. So we can use this in collisions. So using this in collisions, momentum is conserved. So this just means that the total momentum of a collision before objects collide should be equal to the total momentum of the objects after the collision. And that can be demonstrated using this equation. So basically what you would do is you would add up all of the momentums of the objects before the collision, again just by using that equation P equals mv, and just add those together. And then these should be set equal to the total momentum of the objects after the collision. So these two should be equal. So using this in an example, we have two objects that are going to be colliding. One is 10 kilograms and the other is 5 kilograms. The 10 kilogram object is moving at 12 meters per second east, and it's going to be colliding with a 5 kilogram object at rest, so its velocity is 0. So after these objects collide, they are going to stick together, and what we need to be calculating is the final velocity of the objects after they collide. So we can use the equation that we just talked about before, basically calculating the total momentum before the collision, and then we need to set that equal to the total momentum after the collision, and we can use this equation to ultimately solve for the final velocity. So first, let's calculate the total momentum before the collision. So we can just use the momentum equation, and what we need to do is we need to find the momentum of the 10 kilogram mass and add that to the momentum of the 5 kilogram mass, and then these added together is going to be the total momentum before the collision. So just plugging in numbers, we plug in 10 kilograms and it's moving at 12 meters per second, and we're going to be adding that to the 5 kilogram mass, and it's at rest, so it's moving 0 meters per second. So we multiply 10 times 12, we get 120 kilograms times meters per second as the momentum for the first mass, and then we just get 0 for the momentum of the second mass because it's not moving. So we know that the total momentum before the collision is equal to 120 kilograms times meters per second. So now what we need to do is we need to calculate this part of the equation. We need to calculate the total momentum after the collision. So we are made aware that after the collision, the two objects stick together. So now these become and can be counted as just one mass. So what we can do is we can add 10 kilograms plus 5 kilograms and we get 15 kilograms. So this is going to be our final mass. So now that we know our final mass, we know that momentum is P equals mv. So we have our final mass, we have our final velocity, which is currently unknown. And due to the conservation of momentum, we know that this final momentum needs to be equal to our initial momentum that we calculated up here. So it needs to be equal to 120 kilograms times meters per second. And so now we're just left with a basic algebraic equation that we always see, just a number times a variable is equal to a number. So we know that we need to divide by 15 in order to solve for our final velocity. So 120 divided by 15 gives us a final velocity of 8 meters per second.